Hello, I would like to show you today how to build a 1-bit comparator circuit, and the first step is to build the truth table for it. I will open a spreadsheet. The first logical variable, Boolean variable, is A, then I have B, then A smaller than B, A equal with B, and A bigger than B. So these expressions are the output expressions. Let me format it a little bit. Okay, so I have the following situation. A is 0, B is 0, A is 0, B is 1, A is 1, B is 0, and A is 1, B is 1. And let me format it again to put everything in the middle. So I have this situation. Which is the result of the A less than B when A and B is 0, so they are equal? The result is 0. This is false. A is less than B when A is 0 and B is 1 is true. Then everything else is false. Then for A equal B, A0, B0, it's 1. If they are different, this expression is false, is 0. If they are 1, they are equal again, so it will be 1. A bigger than B, this is 0. This is 0 again. Now A is 1, B is 0. It will be like this. Then when A is equal with B, again it is 0, because A is not bigger than B. And that's it. I will save this just so in a directory of its own. Give it a name. Truth table. Okay, and with this I can start thinking about the way in which these, let's say, sub-circuits can be implemented. A less than B is true only once, when A is 0 and B is 1. So I will have something like A less than B. Then I have not A, I will put it like this, not A and B. Then I have A equal B. I will have not A and not B. I will put like this, or A and B. And then A bigger than B, I will have A and not B. Save. Let's format it a little bit. Lowercase. And that's it. Now I can start working with Logisim in order to build the circuit. I will open Logisim Evolution. put it in here. I know that I have 2 inputs and 3 outputs, C, D, and E. I will go to wiring, pin, another one like this. Then I'll have to add another 3 for the output. I have to label them A, cancel, B. Then I have to change the properties to make them output, to change the orientation to west, and to put in here A less B. Then I have to do the same thing in here to change the orientation to make it output A equal B, and I have to select this one, change orientation, yes, and A bigger B. Now, before building the circuit, it's good practice to implement unit tests. And maybe they are not really unit tests as in programmer, but still they are tests. So I will save it, and I will go to projects here, comparator, and I will put a comparator like this. Okay, I have to put comparator circuit like this. Now I have to build, in order to test it, I can use a test vector, and this file in here I can load it, and if I load this file, which will be a reflection of the truth table, then I can run tests to see if my circuit works properly. Now I will go and build this specific test file, which has a certain format. Let me do it like this. Gedit. Like this. Now, my inputs are A and B, and I will put like this: A, B, A less B, A equal B, A bigger B. And I will just copy the truth table from before in here. I will copy this truth table. 0 is 0. If that is the case, then this is 0, 1, and 0. 0, 1, it's in here is 1, then is 0, and in here is 0. 1 and 0, this is 0 in here, then I will go with 0 and 1. 1 and 1, it's 0 in here, 1 in here, and 0 in here. I will save it again, put it into a directory. Comparator, no, sorry. comparator.txt. Let's see what I have. I'll close this one and let me increase a little bit. Sorry, let me increase the size like this. Then I will go with NAND Digital Logic 3D Comparator. Okay, it's more comparator.txt. So this is the unit test file, if I can say so. In order to go forward, we have to load it, and I will load this test vector. And run it. And I will reset it and run it again. And what do we see? That we fail. And why we fail? Well, we fail because it is not implemented and the output, it is undefined. A and B is what it is, and in here the status is failed. So I can do something like this. I can build the test vector and then starting to implement my circuit step by step and checking periodically what I've did. I will start with A less than B, and the expression for A less than B, the expression which has to be implemented, is not A and B. So I will I will choose a not gate, and it will be put in relation with B through the help of an AND gate. And I will add it like this, and then I will connect B to it, and I will connect also A to it. Sorry. And then I will connect the output to A less than B. And let's see what we have. I will have to save it. It is not a condition, but still. And let's run it. If everything is okay, but first let's do it by hand. A less than B is 0. If I put B0, it is still 0 because A is bigger than B. If I put 0 in here, it's equal A0, B0, so it's false. And if I put 1, it should become 1. But this is okay. But it's difficult to test again and again and just to look visually of what is going on. Also, it is very useful. So I will run my tests. In principle, if everything is okay, I should have the correct values for A less B and the failed tests for A bigger and A equal. Let's run it. And here they are. So they failed. Okay, they failed because of these two. But in here, we have the correct values. I would say, let's do a little bit of testing, just so, because I am curious to see what is happening if I give a certain value in here. So this is wrong, we know. Let's save it. it's okay, it's not and not, so it's something else entirely. That's fine. But what if I run it? If I run this? Okay, so look what is going on. If if I implement the wrong circuit, it will show me in red whatever is wrong. Even, I mean, this is undefined, but if I have the implemented values, it will show with red specifically those values that are not correct. So let's correct. I will correct this one, then a save, and run it again. So run it again. And this is the way in which we can implement the necessary logic for a comparator. Of course, we have to implement the logic for equals and the logic for bigger and so on. And let's implement the logic for A bigger than B. A bigger than B means A and not B. I will add another AND gate in here, connect it, then I will go like this, and I will put a NOT gate and connect it in here, and from A I will come with another wire, so it's A and not B. I will not go forward with testing, manually testing. I will save my file and run the test. And here it is. The results are correct for less and bigger, but they are not yet implemented for equal. And I will not gonna do it. And if you wish, you can do it by yourself. Thank you and have a nice day.